Okay, well, one thing that I like about science is that you can look and describe things in qualitative or in quantitative terms. I like numbers. And that means that when I'm looking at an object, I might describe it by making certain measurements. So for today, we're going to be looking at measurements in chemistry, and in particular, we're going to be talking about significant figures. And that's often simply referred to as SigFigs. When we're looking at taking measurements, I think the first piece of information that you need to know is that when you're taking a measurement, you'll record all the digits that you know with certainty, plus one estimated digit. Now, this tells you something about how good of a measurement you're making. It also tells you something about the sensitivity of your measuring device, how much it's going to cost you. So I'm going to pick up the camera and walk over to two balances. And I want you to look at the difference in these two balances. I'm going to actually take a look at the screens where they're reading measurements. You can see that the balance on the left only records to the hundredths position, while the analytic balance on the right, it goes 4 decimal places past to the right of the decimal. 4 places to the right of the decimal. Now, which balance do you think is going to be the more expensive one? You know, you pay for what you get. And if it's necessary for you to take a reading to the thousandths or the 10,000ths position, that measuring device is going to be much more expensive. So in our classroom, we're going to have balances that are good to the tenths, hundredths, and the thousandths position. And we need to know how to use them and how to take care of these balances. But for right now, let's look at the fact that if we're using the balance on the left, we know to the tenths position with certainty. That last zero is estimated. And the same thing here on the Sartorius balance. We know to the tenths, to the hundredths, and to the thousandths position with certainty. Only the 10,000ths position is being estimated. This device has to be the more expensive and the more difficult to take care of. So the first thing we know is that when looking at significant figures in measurements, we're going to record all the digits that we know with certainty, plus one estimated digit. Okay, now let's continue from there. Let's look in numbers. Now, you can look at a lot of different rules, and I know all the rules, and you will too. But who's going to remember all these rules? So we're going to use a very simple way of determining how many significant figures are in a number. And I call this the Atlantic to Pacific rule. I'm going to draw for you on the board my, I think you will recognize it, maybe, maybe not. But it's getting really bad here. But maybe you can recognize this as the United States of America. And most students know that there is an ocean here to the right of the United States. We call that ocean the Atlantic. the Atlantic Ocean to the right, and here on the left we have the Pacific. The Pacific Ocean over to the right of the United States. Now, how am I going to use this to determine the number of significant figures? Well, I'm going to use the first letter, A and P. Here, and if I'm going to use this rule, if a decimal is absent, the decimal is absent. And I'm going to use the Pacific rule if the decimal is present. Let's take a number and see what we would do. Let's take this number. This number has a decimal present. So since the decimal is present, we're going to come in from the Pacific. Remember, the Pacific is to the left. We're going to come into the first non-zero digit. That would be the 1. This 1 and all other digits proceeding from left to right are significant. They are measured. And so, in this number, we have 5 significant figures. What if we had this number? How many significance would be found in this number? Again, the decimal is present. So we're going to come in from the Pacific all the way to the first non-zero digit. That number and all others are significant. There are 2 SigFigs in this number. Now, there is a different rule for when the decimal is absent. If the decimal is absent, you're going to come in from the right, from the Atlantic side, and you'll come to the first non-zero digit. That number and all others are significant. This number would have 3 significant figures in it. You know, this helps me remember all the rules that I really should know. For example, if you have a 0 between 2 digits, then that number is always significant. If you have a 0 to the left of the decimal, to the right of a decimal, but to the left of a digit, that number is significant. If you have a 0 to the left of a decimal and after a digit, that number is significant. But if you have a digit to the left of the decimal, but not between 2 digits, these numbers are not significant. They are space holders. And sometimes it helps us to remember how many significant figures there are. For example, in this second number, if I wanted to write this number in scientific notation, I would write it 2.0 times 10 to the minus 3. That's the same number. When you're using scientific notation, you look only at this number to determine how many significant figures there are. You do not consider the exponential notation. So this rule works for me in all cases. It's quick, it's easy, it gets me into the more difficult problems, which might include things like how we're going to use our significant figures in calculations. There's 2 different types of calculations that we need to think about. These would be multiplying, dividing, adding, and subtracting. So let's take a number that we want to multiply and divide. Let's take a number like, how about 0.450? And let's multiply it by 3.7. Now, I'm lining them up, and when I put these numbers into my calculator, I get, for an answer, 1.655. Let's use our previous rules. How many significant figures are in the first number? Well, there's a decimal present, so I'm coming in from here, that number and all others. So there are 3 significant figures. There's a decimal present in my second number. And so here, there are going to be 2 significant figures. In the calculator, my calculator is giving me this number, which has 4 significant figures. How many can I claim? Well, the rule for multiplication and division is your answer can have only as many significant figures as the number with the fewest number of significant figures. The fewest number of significant figures in the numbers that I'm multiplying is 2. My answer can only have 2 significant figures. Therefore, I have to round this number off. And since looking at this position, I have a number greater than half, I'm going to have to take this number and round it to 1.7. 1.7, 2 significant figures, is all I can claim in my answer. So with the correct number of SigFigs, this is the product of these 2 numbers. Now, if you're adding and subtracting, it's very different. Let's see if I can think of a number that will work well for us. What if I were to take something like 1.07 and add, let me think about this one, 2. I hate having to think of numbers on the spur. Let's just take 2.2. All right. If you add these numbers up, you would get 3.27. Now the rules here are different, and this really helps when I line these up. You see, here I have measured and have a number recorded into the hundreds position. Here with the second number, I only have recorded to the tens position, and this tens position is estimated. I really have no idea what this number is, so there is some uncertainty with this last digit here. When you line up addition and subtraction problems, you go by position. You go by the number with the fewest number of measurement positions to the right of the decimal. Since this number is only recorded to the tenths position, my answer can only be recorded to the tenths position. This means that I would take my number, 3.27, and recording it to the tenths position, my answer would be 3.3. I can only record to the position where I have measured with certainty. So, we'll be practicing this in class. Please remember that the rule for multiplying and dividing is very different from the rule for adding and subtracting. Be careful. Also remember what to do if you're looking at significant figures when you're in scientific notation. I'll add one last thing for adding and subtracting. When I'm adding and subtracting numbers and my number